Here's my tutorial for Le Chatelier's principal worksheet. So we have a reaction. This is all gases, notice. If we decrease the concentration of the dihydrogen sulfide, then some of this disappears. That means that this side is not going to do its job as well, and that's going to be the weak side. Well, if that's the weak side, then that must be the strong side for a moment at least. And this used to be at equilibrium. Notice the double arrows. But just for a moment, it's not going to be at equilibrium. This is going to be the strong side, which means this system is going to be making more left side than it is right side, because the power to make the right side has been decreased because we've stolen some of the dihydrogen sulfide. So it's going to flow left. It's going to shift left. So will this shift to the right? No, because it will go left. And also, this goes back to number 1 and 2. It will shift toward the weaker side and away from the strong side. So by reducing the concentration of this is the weak side, that's the strong side, and it always goes toward the weak side or away from the strong side. Increase the pressure on the system. So that means that things are getting crammed together more than they used to be. And what's going to happen is it's going to shift toward the side that gets out of the way of that increased pressure better. This has 3 gas molecules and this has 5 gas molecules. Well, 3 molecules gets out of the way of the increase on the pressure or the decrease of the volume better than 5 does. So this is going to shift toward the side with fewer gas molecules, and that time that's the left side this time. So will this go to the right? No. Increase the concentration of carbon disulfide. So if I increase this is the strong side now because it has more of what it wants to use to make the left. So the equilibrium will be making more left side than right side for a moment. So this will be shifting left, and no, it won't shift to the right. Decrease the power of the methane. Well, this is the methane. And before somebody says, how should I know that? Well, we know that's hydrogen, and they just named the other 2. So that must be the methane. If we decrease something on the left, that means that the left side is weaker for a moment because it has less of what it needs to do its job. And so it can't make the right side as well. So this is the weak side, and that's the strong side. And it always goes toward the weak side, or to say it another way, away from the strong side. So this will go left. Also, will it go to the right? No. What would happen if the following changes were made? Sulfur dioxide is added to the system. So we're adding some of this. That means that this is the strong side. So this will shift away from the strong side or toward the weak side. It will shift left. Sulfur trioxide is removed. So if we remove this is the weak side now. And so this will go left. Oxygen is added. So we've added something on the right that makes this the strong side, so it will go left. HGO is added to the system. That makes, you know what? That's adding a solid, so no effect. Adding more solid doesn't usually make any difference to an equilibrium system. The pressure on the system increases. Well, the only one out of these 3 chemicals that responds to a pressure increase is the oxygen. So what you're going to be doing is cramming the oxygen down toward the liquid better, stronger. So these should be able to meet more than they used to, more per second or per minute. So that makes this the strong side. It's going to do a better job than it used to. So things will go left, away from the strong side or toward the weak side, whichever way you want to say it. If we have the volume increased, gas, 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 gas. Okay, so 5 molecules of gas and 4 molecules of gas. If we increase the volume, the balloon is getting bigger, whatever the container is getting bigger, and that should favor the side with more gas molecules, because more molecules fill a bigger space better is one way to look at it. And this is a situation where 5 is more than 4 gas molecules, so this will go left. So the effect of decreasing the volume. So this is the opposite. Again, like I was saying the other day, if you do the opposite, you get the opposite. So if we're decreasing the volume, we're going to shift this toward the side with fewer gas molecules, because if the volume is shrinking, then we want the side with fewer gas molecules. That gets out of the way of the shrink better. Fewer molecules fits into a smaller volume better. So we have 3 versus 4, so this will go left. I have double check. Yes, these are all gases, all gases, all gases. Because remember, we're not going to count things that aren't gases. So I should have checked for the gases first. This is 5 versus 3. And so the side with fewer gas molecules is to the right this time. And 2 versus, they aren't all gases. Aha. So this is 2 versus 1 molecule of gas. So it will go to the right. Decreasing the temperature. All right, a new idea. So energy or heat is on the right side. So the right side considers the energy to be sort of a reactant to make the left side. So if we decrease the heat, we made this the weak side. It can't do its job as well as it used to because it needs energy, and we're decreasing the temperature. We're stealing energy out of it. So this is the weak side for a moment, and that's the strong side, and it always goes toward the weak side or away from the strong side. So again, if you have the opposite, you get the opposite kind of thing. So we're going to decrease the left. That makes it go left then. And this is basically the same question as A, and it will go to the right. If you remove a chemical, it will shift toward that side. And before somebody says, but that's a solid, I was saying that the pressure doesn't change anything about the solid. But if I remove solid here, then it has less ability to break up and make that. If I had 10 of these and I remove 4 of them, well, there are only 6 of them left over that could make this. So the amount being made per second has got to go down. So if I remove this, this is going to make the right side less than it used to, which means it's making more left than it is right, which means the system shifts left. The pressure decreases. So this is the only one that cares, the only gas. If I decrease the pressure, there's more room for this to get away from its other chemicals in here. Or to say it another way, if I spread this stuff out, it's going to bump into that less, isn't it? Which means it reacts at a slower pace. One of these meets one of those fewer times per second. So this side doesn't do its job as well if I decrease the pressure. They meet less and they react less, which means this side is making that side less than it used to. This side is unaffected, so this direction to the right is working better than that direction to the left. So it'll go to the right. If the volume is decreased, gas, 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 gas. Okay, so that's 2 molecules of gas and 2 molecules of gas. So there's no effect because there are equal numbers of gas molecules on both sides. So that's their trick question there. If it's equal, then there's no effect. Decreasing the volume should go toward the side with fewer gas molecules. 3 and 2. So the right side is the least. Solid gas. Be careful. 4 gas and 3 gas means it goes to the right. 2 gas and 5 gas means then this goes to the left. If I'm looking to shift to the right, increase the concentration of CS2. Increase this side makes something on this side makes that the strong side, meaning it'll go left. Decrease the pressure means it'll go toward the side with more gas molecules, and that is 3 versus 5. So that should go to the right. Increase the temperature. You know what? That one's unfair because we don't know where the heat is, so we're going to skip that. Decrease the concentration of carbon disulfide. This goes down, which means this is the weak side. So everything will go to the right. Decrease the concentration of hydrogen. Again, this is the weak side. If we remove some of that, so this will go to the right.